Alrighty, take 3. So, my goal, I'm going to do E, F, G, and H, and then you guys are going to do 9 through 12, and then we're just going to start fresh tomorrow. So, I'm just going to do these next 4 problems, and then we're going to call it quits. Okay, so minor difference here with E, F, G, and H in the fact that your index is changing. They're bumping this up, and we're going to work with cubed roots instead of square roots, okay? That's the main reason I had you guys write down the first few perfect cube numbers, okay? Now, the other thing with cubes is that, remember, you can have negatives. You can take the cube root of a negative number. Odd roots or odd indexes, you can have negatives on the inside. Even indexes, you can't. So, when you are looking at this, you can take the root of a negative number as long as the index is odd. Your first task with this is to figure out, okay, how can I break this down? I know that 128 is not a perfect cube number. And if I look at my list, there's what, 1, 2, 3, 4 real possibilities that you could use to help you simplify this. Okay, so again, if you take your calculator, and obviously I know you can see this part over here, so I just want you to get in the habit of, you might have to take 64 divided by the first perfect cube that's right below it, or excuse me, why am I writing 64? I mean 128. So 128 divided by, okay, well, I know 125 is not going to work, but what if I take divided by 64? So 128 divided by 64, okay, that's going to give me 2. Okay, so maybe start with the next closest and work your way down. And so they start by breaking this up into the square root of negative 64 and then the cubed root of 2. Cube root of 2 you cannot simplify any further, but you can take that, or you can take this piece and simplify it down so that it's negative 4. So your answer is going to be negative 4 cube root 2. Letter B, again, is if you look at, excuse me, letter F, if you look at letter B, that's right above, so in the upper right-hand corner of our examples, exact same type of problem. All they're doing is they're just changing it to a cube root instead of a square root. So they want you to be able to figure out, okay, cube root of 125, if we look at our list, that is a perfect cube number. So we're good to go there. This is going to end up turning out really nicely for us. And then the other piece, we have to look at this cube root of x to the 7th. So remember when I was talking before, we want to have multiples of our index. Okay, so we want to break this up into groups of 3, if at all possible. So we might say the cube root of x cubed, so there's 3 of them. The cube root of x cubed again, so there's 6 of them. And then the cube root, I have 1 left over. So 3 plus 3 gives you 6, plus 1 more gives you 7, which is the exponent underneath the root. So cube root of x cubed, again, these pieces are just going to cancel out. These pieces are going to cancel out, which means that this is going to turn into an x, this is going to turn into an x, and this is just going to stay as the root of x. So this right here, remember, we just talked about this today. X times x is x squared. Okay, make sure that you got that. Okay, so they just break it down so that it's 6 and 1. I don't care, however you choose to do it, however you can see it the best. But this is going to be 5x squared, because remember, x times x, so that's where the x is coming from. The cube root of 125 is giving you the 5. Okay, so that's where these pieces are coming from, and you can't simplify that cube root of x any further. Letter G, again, is the exact same type of question as letter C is right above it. The cube root of 216, if you look at your, for your examples that are right above it, G and C are the exact same type. First, we take this and we break it down into 2 separate perfect cubes. 216 is one of our perfect cubed numbers, so this cube root of 216 just turns into 6. We cannot simplify that any further, so we just leave it as the cube root of y. Letter H, very similar to letter D, again, where they are just kind of trying to reinforce that first thing you want to try and do is just separate. So separate this into the cube root of 8x to the fourth, the cube root of 27y cubed. Your denominator, again, turns out to be a nice perfect cube for you. So you can change that so that it's the cube root of 27, the cube root of y cubed. Cube root of 27 is going to turn into 3. The cube root of y cubed is going to turn into y. Kind of a similar concept as before. This cube root of 8, again, is a perfect cube. You want to break that cube root of x to the fourth up into as many groups of 3 as you can. Well, there's only one that you're going to be able to, so it's got to be the cube root of x cubed and then the cube root of x. So these will cancel. That'll leave you with x and then the cube root of x. Okay, one thing to keep in mind, you guys, you cannot take out more than what you have. Okay, and then we just go ahead and simplify. And I think my technology just stopped on me again. So it's a good stopping point. I think that's my cue just to be done. Okay, so go ahead, make sure that you get 1 through 12. Those examples all need to be done for tomorrow. We'll go through them. We'll work through them together in class if you've got any questions. And then we'll do part of the homework assignment tomorrow. And then I'll just continue adding videos until we get through section 1. If you've got any questions, feel free to email me. Otherwise, I will see you guys tomorrow. Have a great night.